Today we have several things we get to talk about: radians, degrees, reference angles, and coterminal angles. In this first example, we're asked to draw an angle in standard position, and then we're also asked to convert this angle from degree to radians. So I'm going to take you through both parts. In order to draw an angle in standard position, let's first draw our XY axis. One of the things that you need to know is that we're going to be following the way that we label a unit circle. As far as the degrees, a unit circle will start here at 0, and we're going to progress counterclockwise. As we move to the left, we come to 90 degrees. As we continue, we get to 180 degrees. Continuing more on our circle, we get to 270. And as we finish out our circle, we come to 360. So if our angle measurement is a positive angle, we're going to proceed counterclockwise to find this angle. So if I start at 0, I'm going to come around to 90, but I don't stop there. I need to go just a little bit past 90 to about 110. At this point, I'm going to connect from my 0, my origin, to where I stopped to create the terminal side of this angle. The angle I have drawn represents 100 degrees, with the x-axis as one side of my angle and then my terminal side drawn here. Now let's convert this angle measurement from degrees into radians. The way that we do this, if we want to take something in degrees and change it into radians, is to multiply by pi over 180. Now, if you're using your calculator to do this, you're not going to want to put the pi into your calculator. Only put the numbers into your calculator. And if you use division, it may give you a decimal answer. Remember that you can convert your decimal answers back to a fraction by doing math inner. This particular one is going to reduce to 5/9. Do not write a decimal answer. Make sure you write it as a fraction. Your pi can be written behind the fraction, or you could write it in the numerator. In example 2, you have a very large angle. One of the things I want to remind you, every time you make a full circle, you have traveled 360 degrees. So if I go around the circle one time, it's 360. 2 times would be 720, and 3 times would be 1080. You can see 960 is more than 2, but not quite 3. So when I'm drawing this angle, I want to start off, I'm going to go around one time, and I'm going to go around a second time. Now, how do I know how much further I'm going to go? Well, I have traveled 720 degrees. If I subtract this from 960, I can see that I need to go 240 degrees more. So starting right here, I'm going to travel 180 degrees, and then the last portion, not quite to the 270. Since I stop here, I'm going to connect from the origin to this point so that I can create my terminal side of my angle, and I'll label this 960 degrees. Again, because it was a positive angle, I traveled counterclockwise. If you ever have to graph a negative angle, you will travel clockwise. Now let's change this from a degree measure into radians. If I take 960 and I divide it by 180, my final answer is 16/3 pi. In these next two examples, we're asked to convert from radians to degrees. In order to make this transition, we're going to multiply by 180 divided by pi. The reason pi goes to the denominator is because we are hoping to cancel out the pi so that it no longer remains in our answer. So in your calculator, if you will do 8 times 180 and then divide that answer by 3, you'll get 480 degrees. We'll work this problem the same exact way. We're going to multiply by 180 divided by pi. If I multiply 17 times 180 and then divide it by 9, I get 340 degrees. In these last two examples, we're asked to find 3 things. They want us to find a reference angle, and then they want us to find both a positive and a negative coterminal angle. So it's important that you understand what they are. The reference angle is always going to have a positive value, and that's very important. The reason it is a positive value is because it is measuring the distance from the terminal side back to the x-axis. There's an angle that is created here, your inner angle. Since I'm given some information that I can use, this entire angle that has been drawn is 390 and terminates at this side right here. That is my terminal side. I know that if I make one full rotation, I have traveled 360. So I just need to find out what the difference between these two values is. 390 minus the 360 tells me that this angle is 30 degrees. So my reference angle is 30 degrees. Now they want me to find a positive and a negative coterminal angle. I'm just going to call this the PC and the NZ. Coterminal angles are infinite. You can find tons of them because a coterminal angle is simply an angle that ends at the same place that your angle ends at. If I want to find another angle that ends at the same place as mine and I want it to be a positive number, I could just continue around the circle one more time. So what I've done is I've taken my angle and I've added 360 degrees. In this case, I will get 750 degrees. It just tells me that is another angle that ends or terminates at the same place. If I'd like to get a negative coterminal angle, I can do this same method. But instead of continuing around in the same direction, let's back up and go the other way. Remember, positive 360 means that I am traveling counterclockwise, but negative 360 means that I am traveling clockwise. So what happens if I take my current angle and I subtract 360? Well, in this case, I actually got another positive angle. The angle 30 degrees also terminates at that same location. But I don't want the positive. Let's subtract 360 one more time. Now I have a negative angle. This one tells me that if I start at 0 and I travel negative 330 degrees, I am going to land at the same exact place. So here's my positive coterminal, and here is a negative coterminal angle. All right, let's do this one more time. In order to find the reference angle, I want to find the measurement from my terminal side back to the x-axis. I'm measuring the angle inside of these two places. You might have to get a little bit creative. One of the things that you know is that a semicircle has a measurement of 180 degrees. Here, we've traveled 150. Now, you might be looking at that negative sign and thinking, well, I've traveled negative 150. You need to remember that negative only refers to the direction. So if this represents 150 degrees and a full semicircle is 180, I know that my reference angle is 30 degrees. And remember, reference angles are always positive angles. Now let's find a positive coterminal angle and let's find a negative coterminal angle. Just like we did before, we're going to take the angle that we have, negative 150. I'm going to start by adding 360. That gives me a coterminal angle of 210 degrees. If I'd like to get a negative coterminal angle, I'm going to continue in that same direction. I'm going to subtract 360. And that gives me a total of negative 510. So just to go over this one more time, if I was to draw a 210 degree angle, it would stop right here at the same place as my angle. If I was to draw a negative 510 degree angle, it would stop right here at the same place as my angle.